All right, welcome back to week 10 about polygons. Let's talk a little bit of a warm-up. Definitions of an angle, a representation of a turn or a rotation, the intersection of two rays at a common vertex, the space between two rays, and remember, you should be able to think about these different interpretations and what are their benefits and what are their drawbacks. Try to do this. Name these geometric figures. So the first one is an example. It's done for you. You could call it line TS or line ST, or you could use the symbols with a line over the top of the two capital letters with arrows at both ends. And remember, with a line, order doesn't matter. So try these next few and then check your answers. How'd you do? Did you get line segment CD or DC? Again, order doesn't matter on line segments, and this time the symbol is just a line with no arrows on the ends. Number 2, ray XY or XY with a line over the top, but the arrow is only pointing on one end, and it has to start with X and end with Y. It cannot be ray YX. Because order does matter in a ray. We always start with the end point because it only continues in one direction. Similarly with number 3, ray QR, and then 4, point L, and then 5, line segment NO or ON, either way. How about these? Do you remember these? Straight angles, supplementary angles, complementary angles, or vertical angles? Think about each one of those definitions. Now let's review those. So a straight angle is an angle measuring 180 degrees. A supplementary angle, two angles that are not necessarily adjacent, are supplementary if the sum of their measures is 180 degrees. Complementary angles are two angles, they don't have to be adjacent, are complementary if their sum of their angles measured is 90 degrees. And then vertical angles or opposite angles. Two opposing angles formed by two intersecting lines. These angles are always congruent, meaning they have the same measure. All right, so there's some definitions. Now let's take a look at some pictures and try to make a match. So, can you tell which figure is a straight angle? Which figure is a supplementary angle? Which one is a complementary angle? And which ones are vertical or opposite angles? Did you get them right? The straight angle is C. The supplementary angles are A in figure A. So this angle and this angle sum together to 180 degrees. Whereas the complementary angles, these two angles, angles A and B in this case, sum to 90 degrees. And then D, vertical angles are the ones that are across from each other. So in this case, C and A are vertical angles, and B and D are vertical angles. And so A and C would have the same measure, and B and D would have the same measure. So try to answer the question, how does the measure of a straight angle relate to the measure of two supplementary angles? And then also, can a pair of acute angles be supplementary? Why or why not? Think about those two questions before you move on. So a straight angle is 180 degrees, and two supplementary angles sum to 180 degrees. Two acute angles cannot be supplementary because the definition of an acute angle is it's less than 90 degrees, and supplementary means they must sum to 180 degrees. So the largest angle you could have in whole degrees is 89 degrees, so 89 degrees plus 89 degrees would only be 178 degrees, which is less than 180 degrees, so therefore not supplementary. Here's some angle relationships. This is nice for you to copy down and see how many angle relationships you can find in the figure. And then for each relationship, can you figure out why the relationship holds? For example, A and B are supplementary angles because the sum of those two angles are 180 degrees. But I also know that A and C are vertical angles, so they must have congruent measures. And then I know that B and C must be supplementary because they sum to 180 degrees. So there's a lot of different options here. I hope that was a good reflection on angles and you're ready to start the week. Because this week we are going to be looking at polygons and how to specifically define, identify, visualize, draw, classify, and analyze 2- and 3-dimensional shapes, including the characteristics and attributes of these shapes. And again, we're going to practice MP1 and MP6.